Hello everyone, in today's video I'm going to discuss about the origin of displacement current. So we have learned in Ampere circuital law, that is, if we take the line integral of magnetic field around a closed path, it is equal to mu naught times I enclosed. That is mu naught times the current which is enclosed by the closed loop, that is the Amperian loop. So this is the Ampere circuital law. So we have learned that electric fields are produced by charges. So electric field is basically produced by charges. So we have also learned that in Faraday's law, electric field can also be produced by changing magnetic flux. So the two sources of electric fields are charges and changing magnetic flux. So which is given by Faraday's law. So this is the changing magnetic flux. So when you change the magnetic flux linked through a coil, you can produce an electric field. So, and we have also learned that magnetic fields are also produced by currents, that is moving charge. So the question that arises in our mind is that, so if changing magnetic flux can produce electric field, so since nature loves symmetry, so if I change the electric flux which is linking through a coil, can it produce magnetic field? So this question crop up in the mind of Maxwell. So Maxwell, so he took a charge capacitor. So this is a charge capacitor. So in this charge capacitor, this is the positive plate, I call it as plate P, and this is the negative plate, I call it as plate Q. So electric field exists between the plate of the capacitor. So initially I made this capacitor to discharge. So when I made this capacitor to discharge, the current will flow from plate P to plate Q through this resistor R. Through this resistor R. So, so the electric field between these plates of the capacitor will vary with time. Will basically vary with time. So I'm going to apply Ampere circuital law to this tiffin box or to this pot with a lid. This is the lid. So I call the surface of the lid as S1 and this surface as S2. So this surface S2 is between the plate of this discharging capacitor and the loop as L. So I'm going to apply Ampere circuital law to this surface S1 and to this surface S2. So when I apply Ampere circuital law to this surface S1, this is B vector dot dl vector. So the current I is threading through this surface or this loop, so this will be equal to mu naught I. So when I took this surface S2, this is for surface S1, when I took this surface S2, so look at this surface S2, that is the bulge portion of this pot. So through this bulge portion of the pot, there is no electric current which is threading through this bulge portion of the loop. Why? Because this bulge portion of the loop is between the plates of the capacitor. So since the medium or material between the plates of a capacitor is dielectric, there is no flow of current across the plates of this capacitor. So let us apply Ampere circuital law. So since no current is threading through this surface S2, so this will be equal to 0. So when I calculate this magnetic field through this same loop, there are two results. So at first, there is a non-zero magnetic field. In the second one, I got a zero magnetic field. So this is the inconsistency of Ampere circuital law. So this was also proved experimentally. So when I measure the magnetic field here and between the plates of the capacitor, so when I measure the magnetic field here, there is a certain magnetic field that is detected by the deflection of the compass needle. And when I place a compass needle between the plates of the capacitor, there is a certain deflection in the compass needle, meaning that a magnetic field exists between the plates of the capacitor. So, so that origin of the magnetic field between the plates of the capacitor is nothing but the displacement current. That is the displacement current. So this displacement current is not a physical current, but it is a term which arises due to the changing electric field or electric flux between the plates of the capacitor. So whenever you change the electric flux or electric field, you will get displacement current. So displacement current is actually a term which gives rise to a magnetic field. Its role, its function as a current, that is displacement current, give rise to a magnetic field. So you must note that although its name is current, it is not a physical current. It is a term which arises due to changing electric flux between the plates of the capacitor, which ultimately give rise to magnetic field. So this displacement current ID, I will call it as ID, is equal to epsilon naught derivative of phi e with respect to t. Phi is nothing but the electric flux. So this is the displacement current. So this displacement current has the same unit with current, that is ampere, and it has the same rule with your conduction current that is flowing through the wire. So when we take a circuit, we have to take two types of current, that is the uh, displacement current and the conduction current. Conduction current is actually the physical current. So in Ampere circuital law, Ampere have left out displacement current. So that the inconsistency that we have discussed is due to the missing part, that is the displacement current. So Maxwell steps in and added displacement current to Ampere circuital law, and that law will be called as modified form of Ampere circuital law or Ampere Maxwell law. Ampere Maxwell law. So this is modified line integral of magnetic field is equal to mu naught conduction current, that is the current which is flowing through the wire, plus I displace. So this becomes to mu naught. This is the conduction current, and the expression for displacement current is, I have discussed, this is equal to epsilon naught d phi e by dt. So this displacement current is responsible for the propagation of electromagnetic waves in vacuum or material. So without this displacement current, the propagation of electromagnetic waves will not be possible. So this term is called displacement current because This term is due to the displacement of the uh, displacement field. So Maxwell solved the inconsistency and in Ampere circuit law. So this is the basic idea of displacement current. So thank you all. Stay tuned for the next video.